Okay, so we're in chapter 6, section 6.1, and we find that if we go and find the slope of a curve and then move up on that curve, we might be able to come up with a solution. And so on page 432, we find that we have some dy dx, some differential equation, and that's some function in x and y. So I got some function in x and y, and I'm going to go and I'm going to find the next value. Y is equal to n plus 1 is going to be yn plus some step. H is some step, so that might be 1/10 of the way or 1/4 of the way, or it might be a whole inch or something. So some step times the function at x of n, y of n. So I look at that and say, okay, well, I know the function at f of xn, y of xn. I know that point. It's sitting right there. And then if I go and I find some step up here, and I have some slope that gets me there, and I'm gonna approximate the answer. There's my answer, and I'm gonna approximate it as I go and see how close I can get. Okay, so that's the plan. All right, and we're going to do that with Excel spreadsheets, and there's prettier pictures of that in the book. But we'll start with number 2. All right, so number 2 says y prime is equal to 2y. Okay, and y at 0 is a half. And if I go and I solve this differential equation, I'm going to have y of x is equal to 1/2 e to the 2x, right? Because I can use chapter 1 and I can say I have a characteristic equation. My characteristic equation is m minus 2 is equal to 0, m is equal to 2, so y of x is equal to c e to the 2x. Y at 0 is a half, implies c is equal to 1/2, and my solution is going to be that guy there. So I know the solution already. That's not the issue. In fact, I picked the function on purpose, so it'd be easy, so I would know the solution already. Now the issue is, can I do it in a spreadsheet? Okay, so what I need is a piece of paper that has written down what I'm supposed to do on it, so that I don't have to go back and forth. So I've got y n plus 1 is equal to yn plus h times f of n plus n. All right, so I got that. Okay, so I got what I got, and I've got that y prime is equal to 2y, which is the function f of xn, yn. Okay, so now I'm all set. I move to my spreadsheet, and the problem says I want to compute this with an h of 0.5, and then with an h of 0.1, and I want to be on the interval 0 to 1/2. Okay. So, what do I want to do? Okay, we'll skip the first guy. We'll come here. We'll call this guy y of n. Y of n. And we'll call this guy h. And we'll call this guy f of x and y and we'll call this guy y of n plus 1. Okay, that's what we're going to call that. And then over here we're going to put the real answer. Real answer. And over here we're going to have an error. So we can't get here from there. So here we're going to put the error. Alright, so that's our plan. So we're going to do the calculation, and then we're going to figure out what the real answer is. Okay, so y at 0 is a half. Right, y at 0 is a half, so we put in a 0.5 there. And we're going to do 0.25 is our h. And our y of xn, okay, so that's going to be 2 times equal sign. Where's the equal sign? Equal sign. 2 times b 2. 2 times b2. Okay. And then this guy is going to be equal sign. He's going to be b2 plus h c2 times d2. Okay. And that'd be good. And then this is going to be E2 because we're going to take the value we had there. This is going to be C2. We're taking the value we have there. And here, what do we want this to be? Did we put the right thing there? Yeah, 2 times b2, right? So we can just copy these other two guys. So we'll do a control, get out of there, stupid wire anyway. Control copy, control paste. Okay, so this is at 0. That's at halfway there. This is all the way there. That's my answer. Alright, so now, what's my real answer? Well, my real answer is 1/2 e to the 2x, right? So this is going to be equal to 0.5 times exp to the 2 times x. What is x? What is x? X is going to be A2 times C2. Alright, so here we're going to put a 1, and here we're going to put a 2. So those are my steps. And then the error is going to be G2 minus E2. Oh. So there's my error. And then we're going to go in and do a copy there, and we're going to do a paste here. So now we're done with the first half of the problem. We see that our answer is getting worse. That's terrible. But That would be the answer to my problem in numeric form. Now we're going to do it. All right. So now we're going to do, we're still on problem 2, and we're going to do it with a 0.1 h. So my h is going to be 0.1. I'm going to start with the 0.5. And these guys are going to get copied. Control copy. And then these guys are going to get copied. Well, no, we're just going to go all the way across. Control copy. And that's 1, 2, 3, 4, 5, right? Control V. Okay. And then we need a 1, 2, 3, 4, 5. And we really don't need this last step, 6. We'll put a 6 there, but we really don't need it. All right, so I'm finding that my answer, y of x, are these numbers. I'm finding that the real answer would be those guys over there, and I'm deviating just a little bit from the real answer as I go down. Okay, so that's what we do. Questions? No. Now, if you have to do it with a calculator without a spreadsheet, then you're just going to make an error someplace. It won't work. Okay. So now we're going to do it again. So that was problem number 2. This is problem number 2. All right, now we're going to move down on the same spreadsheet, and we'll do problem number 4. Number 4. Okay, and in fact, we'll just copy problem number 2 in problem number 4, just for the heck of it. Copy, paste. Now this is not problem number 4 yet, because we have to change the initial condition. We have to change the problem, right? But all the manipulation of what we do is going to stay the same once I do that. All right, so problem number 4 says my initial condition is 1. So we'll change the initial condition to 1. We're still going to use the same h there. We'll change the initial condition to 1 down there. And what was D? I guess I should have copied this so I know what the heck I'm doing, right? Copy, paste, and we'll move this just a little bit that way so I have a little more room. Okay. So now I want to know the function is going to be not 2x, but it's going to be x minus y. Okay, so it's going to be x minus y. Okay, so x is going to be what? X is going to be b2 minus 1. No, it's not. It's going to be A13. A13 minus 1. So A13 is now a 1, but it has to be a 0 because that's what x of n is. Okay, minus, parentheses, minus y. What is y? Y is B13. B13. Alright, now x of n plus 1 is h times that guy. Okay, so that's good. Our real answer Okay, so our real answer is going to be 2 times the exponential of minus x. And x is going to be b 13 minus 1. Okay. Plus x, which is b 13 minus 1. Minus 1. Minus 1. Delete, 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 delete. I've got one too many, one not enough parentheses. I need one more there. So 2 exponential x minus 1 minus x plus x minus, okay, boom. Okay, excellent, excellent, excellent. This guy is E13, yes he is. That guy's the same guy. Now I'm going to go and copy these guys, copy, paste. Alright, so I see that my error is small, relatively small anyway, and I'm there. Alright, so how do I correct the other H guy? Okay, so I got this guy's the same, H is that. I'm going to copy this guy into here. Control V. Okay. Wow, that's a whole lot different. 0.1, 0.9, 0.91. So these guys are not right. Yeah, these guys are right. These guys are just copying those from over there. I think that's probably right. We're getting a bigger error than we should. The let's look at this. E to the minus B21. Yeah. Well, there's no reason to think that that's not right. Alright, so we're done with problem number 4. Now, the thing of it is, we're using Euler's method to do these things. So you think of a time, no calculator 200 years ago, I'm not going to do a lot to solve a differential equation, so I have to make it easy, right? If I'm going to use numerical methods, no spreadsheets. Okay, got to do the math in my head. Okay, so that would be perfectly okay. In section 6.2 and 6.3, we use different methods that are more complicated but get a better answer. So we're going to get an answer quicker, sooner. I guess I need to do problem number 6. Well, I don't have to do problem number 6. I could just go find where I did problem number 6 last and just put it in, right? I could do that. I'll probably do that anyway. But, all right, so we'll go and copy. In fact, we'll, oh, that's good enough. We'll just copy that one. Paste. All right, so we're going to do problem number 6. Okay, so I'm doing problem number 6. Excellent. And then we'll just copy all these guys into problem number 6. And then we'll change them to be better. Alright, so problem number 6. My initial condition is 2. So I put a 2 here, and I put a 2 there. I'm doing the same value of h, a quarter and a tenth. My function is minus 2xy. Okay, so this is going to be minus 2 times, and I already have an x, so I'm going to keep it, times y. Y is going to be b25. Okay, so delete b25. Boom. Okay, and my e guy is that guy, which is going to be b25 plus c25 times d25, right? And then my answer, my real answer to the problem is 2e to the minus 2x squared. Okay, so I have 2e minus 2 raised to the squared, close parentheses. Boom. Oh, that doesn't look good. Oh, wait a minute. Let's look at it again. Okay, so I got 2e to the minus x squared. Okay, so that should be 2 to the 0. Yeah, so that looks right. Obviously, I've got a big error, though. That's not cool, but that is probably okay. We'll go and do a copy, and we'll do a paste like that. Is that as far as we go? Oh, bummer. I'm way over here. Paste. And clearly we don't need that guy or that guy or this guy or that guy. Okay. Well, that looks very unprofessional, doesn't it? How can our error be as big as our number? So we're probably doing something wrong. What is it? Y of 2 is 2.14, 1.6. E28 is right. Okay. This is supposed to be minus 2 times x times y. Well, that looks like minus 2 times x times y to me. And this is supposed to be b28, c28, d28. That's right. Well, it must be true. Here we had a pretty, we had a pretty big error there. Here the error, but why should the error be equal? That seems so weird. Oh, it's 0. That's why, because this number is 0. How can that number be 0? How can, well, I guess so. This times that plus that would be 0. Yeah, it would be. Okay. Well, we'll assume that we got it right. There's no reason to think that we didn't. All right, so now we're going to move to chapter section 6.2. Oh, well, why don't we do problem number, I got an idea. Why don't we do something weird and look in the back of the book and see if the author thinks that our number 6 problem is correct. And then we won't have to second guess ourselves. 7,
I don't really think about filling it up, but I know you can
7, 7,
I know you
chapter 6.
just
All right. Problem number 6 says I should have a real value of 1.558. Why don't I have a real value of 1.558? Alright, so my real value for number 6, 2 times the exponent of minus x, the quantity squared.
you should be able to, like if you project the rest
2
of the geometry, so that when
minus x squared.
you know like that,
X is, I got a calculator, I guess.
so then you should be able to build something up here, so you don't have to do that.
Okay, x is going to be a half. So if I go 0.5
Okay.
squared,
Okay, you wanna
or I'm not on,
make it not like
0.5
flat instead of hollow.
squared
Yeah, you should just be able to
with a
like,
minus sign, bar. Minus 0.5.
and then you should
Second function, e to the x, minus 0.5 squared, close parentheses, boom. This should be a 0.7788. No, I don't have time. Even if I had 0.2. All right. Okay. Okay. All right. What am I doing wrong?
before you like go ahead and delete
That
lines, but before you go and try and
times this.
make sure you close that part.
We forgot to go.
Remember that was open.
All right. All right. Back to real answer. This is that, but this has to be multiplied by C25. C times C25, parentheses, equals. Control copy, control paste, control paste. Okay. All right. Am I doing the same thing? H. This is that times B25 times B25. This has to be times C25 times C25. Okay. Copy. Paste. Paste. Oh, bummer. Copy. Paste. Okay. Is that better?
That's a little better.
5, 6. Problem. This number 6.
Uh,
Yeah, it says values of 1626, which is that guy there, and 175, which is that guy there. So everything is okay except my true value. So my true value is still wrong, but that number and this number, which are the two numbers in the back of the book, are correct. All right, so now we got to figure out what we're doing about this guy. Why can't I get the true value right? 2 times e to the x x squared. That looks right. E to the x squared minus e to the x squared. Anyway, everything's fine except my real answer, which I don't have right. That doesn't just torque you right off. B 31, which is a 6, minus 1 gives me a 5. 5 times 0.1 gives me a 0.5. There's no reason that shouldn't be right. Okay, well, enough of that. Moving on to section 6.2, and we see we have an improved Euler method on page 445. Okay, so we'll go in, how do we do that? We go to sheet 2, right? So we're going to go to sheet 2, and in the improved Euler method, we're going to want a number. We're going to need a y n. Well, y n. Going to need a y n. We're going to need an h. We're going to need a k1. If I can spell k1, k1. And we're going to need a u of n plus 1, u of n plus 1. And then we're going to need a k2, k2. And then we're going to need a y of n plus 1. And y of n plus 1. Okay. Excellent. You like that? Or you just love it? And then we're going to have a real answer. And then we're going to have an error. All right, so that's our plan. And we're starting with problem number 2. And problem number 2 is the same as problem number 2 of the last section. So that means our chances of messing it up are slim and none. Okay, so we're going to start at 0 this time. So we don't have to do the b minus 1 thing. So we're going to start at 0, 1, 2. We're doing interval, we're only doing interval 0 to 5, step size 0.1. So we're going to go 0 to 5. Okay, 3, 4, 5. All right. My initial condition is 0.5. I'm going to do 0.1 all the way across. Okay. Now we're going to do a k1. K1 is the function at x n y n. Okay. So the function at x n y n equals 2 times b2.
It's like this and then like
Right? My u sub 1 plus whatever is going to be the function at yn, which is b2, plus h, which is c2, times k1, which is d2. Okay, and then I want a K2, and K2 is the function at x n plus 1 u n plus 1, which is 2 times the y guy, which is E2. E2. Okay, and then the next guy is going to be y sub n B2 plus h, which is C2 times 0.5 times parentheses K1, which is D2 plus K2, which is F2. And our real guy, we'll just steal our real guy from the other page.
Yeah, he has a name.
So our real guy and our error are those two people. Copy, paste. Okay, looking good. This guy is G2, and these guys are all copied. Copy. Paste. Copy. Paste. Okay, now is that better than our last answer? That's a good question. So I got a the last guy that counts is that guy, 1351. 1351, and the last time we got a 14 something. So 1351. So that's the last time. 1.2, 1.35. So we're getting closer to the right answer. That's all that we really wanted to see. What happened to my spreadsheet?
And I had, that's basically what I really gotten, is that I had to put my nickname, which will be over here now.
Okay, are we happy with that? No, we're not happy with that at all. But from a conceptual point of view, it's pretty simple, right?
And over here.
And our error this time is 0.9. The error last time was what?
40 centimeters.
How come I have a bigger error? Oh, I'm going to have to look at my... Did I not do the real guy right? Real guy is 1/2 e to the 2x. 2 e to the 2x. That's not right. E to the 2x. That should be A2, C2. A2 times C2. Oh. There we go, that's much better. So my real value 1.359, my calculated value 1.351. So that's very much close to each other. And why is it that we're not? Why is it that we're doing this error?
You're not against it all.
The error should be not G2, but should be B2. B2. Oh, that's much better. All right, so that begs the issue, did I do the error wrong on the other page? And the answer is probably yes, I probably did. This should be G2 minus B2.
Yeah, you're off with it.
Copy, paste,
When you can't read something, I'm not talking.
paste. All right, so that looks like a much better better error correction, and we better do it down here too. Okay, so I'm happier about that. I'm still not happy about this real answer for section 6 footer. Okay, so that's our problem number 2. Our error is getting smaller by a significant amount. So our error last time was what was it, 0.4, and now we're down to an error of 0.0079779. So that warms my little heart. All right, so now we're going to do problem number 4, and we'll do we'll copy and we'll paste, and we'll do problem number 4. Okay, problem number 4. Initial condition is 1. My H's are the same. My K1 is the function at x and y. So that would be the x guy x is going to be A11 times C11 minus y, and y is what did I do? Bummer. Delete, backwards. We didn't put this in the right spot. So we're going to delete that. We're going to do a copy and paste and put it in the right spot this time. Copy, paste, problem number 4. Initial condition 1. Okay, H is the same. K is x minus y. A10 times C10. So that's my x minus my y, which is B10. Okay, my y n plus 1. Y n plus 1 is y of n y of n plus h k1. So that doesn't change. K2 is the function at xn plus 1. Okay, the function at xn plus 1. And function of xn plus 1. So that would be x, which is going to be A11 times C11. So that's x n plus 1 and u of n plus 1, which is e, so that'd be minus E11. No, that's not what I want. Alright, so I want x. What do I want? Why am I so hosed? Alright, so I'm looking at K2. K2 is x of n plus 1. Okay, so we'll go with A10 plus 1 times power. We're trying to do K2. AX A10 plus 1 times C10 minus E10. E10. U of that's going to be the same. Okay. The real answer is 2 exponential minus x A10 C10 okay, minus x plus x A10 times C10 minus 1. Okay. I think so. Alright, so we're going to copy these guys into those guys. Alright. Well, I like my error. Do I like my answer? This is 6.2. Is this 6 or 4?
This is 4, I believe.
4. I'm supposed to have a .7142. Do I have a .7142? Yes, I do. Do I have a .7131? Yes, I do. Right here. So that guy, both checks. Problem number 4 is in fact correct. Okay. So what you want to do is make sure you start with the spreadsheet already made up, because now I can continue this problem forever and ever, right? And especially with that small of an error, that's not bad. All right, we'll do number 6. All right, so we'll copy and paste first. Copy
my main thing is I need whatever I need for the presentation before I leave.
Alright, so problem number 6.
Yeah.
Okay,
Whatever-
initial
whatever
condition
the design
2.
concept was, I'm going to leave
Okay,
it
so I
for
got a 2. My H stays the same. My K is the function K. So this guy is going to be minus 2 times x, a 19 times c 19 times y, which is b 19.
You're just gonna scan this one for the presentation, right?
Okay. U of n plus 1. U of n plus 1 doesn't change, it just uses what I have there. Okay, K is going to be the function. Okay, so this is going to be minus 2 times x. Okay, a plus 1 times c 19 times e 19. E 19. Boom. Everybody else stays the same except the real value. The real value becomes 2 exponential minus x squared. Okay, I come across here, I do a copy, and I do a paste, do a copy and a paste, and now we're going to check the back of the book. Boy, I don't like that. That's the same real number I had last time. I didn't like it last time, I still don't like it. 62, number 6. Is this number 6?
Yes.
1.5573. So that guy's right. But for some reason, we're not getting the right real
What I
number.
was saying was like, the picture of the chair that you drew, like the first day.
2 times the exponential
Tomorrow, so you guys can have it, okay?
of x
So then you take it home and just,
squared.
I need to take it home and scan it so it can go into the presentation.
Well, that's x. X squared, that's 0.
Like we were staring at
The exponential of 0 is 0. That's a 2. But why are these things doing something that 20? Do we have an order of operation problem? I don't see it. Could it be that the answer is wrong? The correct answer is wrong? That could be, I suppose. 2 exponential x squared.
Does that have anything to do with that negative sign?
Yeah, but, oh, no, there's a minus sign in here. It's 2 exponential minus x squared. When I put in the 0.5, I get to 0.7788. The book says I'm supposed to. It's just that my spreadsheet's not giving it to me. And that's C24B. So 5. That's 0.5.
Yeah, okay, so let's go ahead and pull the column.
0.5 is a half. So a half squared is a quarter. So e to the minus 0.25 times 2.
Oh, there's your scale. So, like 25. So I don't know if you can.
1.5576. That's supposed to be a 1.5576, and it's not. That is really weird. I've never seen Excel do that to me before. Let's put parentheses around that. Well, not gonna let me do that. Put parentheses around that. There it is. That is really weird. Why would I have to put parentheses around that? It must be an order of operation problem in Maple. That's all I can think of. Alright, well, look at that for my error now. Isn't that cool? 10 to the minus whatever. So this particular method is doing really good on my error. And now we'll go back in and do a control copy of that and go back to the spreadsheet for number 6. Okay, and put it in here. Way to go. Just totally wonderful. That was just so totally wonderful.
Oh. Okay.
Okay, so I want to put parentheses. Oh, I blew that though, didn't I? All right, copy.
That's cool. So we're going to create a shrink version of this. So I'll do it and then we'll never try it.
Paste. All right. 25. A25, C25, right? C25. Well, isn't that just special? Totally special, I tell you. And I think I'm relatively hosed though, aren't I? Yes, I am. All right, so this has to be a minus 1 because I didn't start with 0 on this example. Minus 1. Much better. Now I'm getting what the back of the book tells me to get. All right, that's fine. One more, and then we'll leave the next section to next time. We'll do number 8.
Okay, well,
Notice that I'm doing this by looking at the book constantly to make sure I'm putting the right thing in. Because if I didn't, I wouldn't do that. I would be wrong. Okay, problem number 8. Okay, the first guy is 0.
well, you would,
K1 is the function,
gotta
which is going to be exponential
shoot in the input.
exp minus y minus b28. Okay, that guy is contrived from what I have. K2 is the function. Okay, so be the function. Okay, so it's going to be equals exp minus E28. Okay, and the y guy is calculated, that's fine. Oh, I don't believe it. And the function guy, which I don't believe, I could get an answer that said that. Do you believe that? Is going to be tangent .25 times x. X is going to be A28 times C28 plus pi, 3.141592. That should be good enough, right? Parentheses, parentheses. Okay. Looking good.
No, I've actually put it
Okay, we're going to copy these guys. Error 1. Copy those guys down to there.
It says copy that. Usually it
B.
it used to tell me to just put it in
Wait.
the email.
Do a quick check and oh, I don't like that error. Do you like that error? I don't like that error. So it's number 8. I'm supposed to see a 0.4053. I do, but my real guy is supposed to be 0.4. So I got my real guy wrong again. Okay. So my numeric method is correct. I have the right answer, but my real guy I don't, and that's because the real guy is the natural log of something. So that would help if I put in the natural log of something. Natural log x plus 1. A 28 times C 28 plus 1. Much better. Yeah, that's what I was supposed to get. Okay, questions about that? It looks too easy with me doing it, I know, but You're supposed to do the odd guys. Now, this is the chapter. Let's turn off the volume here. Control Alt